Hello, it's Keith here, and this is lesson 1 of the simple series of my MIPS assembly programming tutorials. In the simple series, we make simple little examples which are typically a self-contained file that does a particular task. Now the task today we're going to do is we're going to draw a bitmap to the screen. So you can see here, we've got a bitmap here. This is the Chibico mascot of this website. You can see it down there as well. And so we're going to draw that bitmap to the screen at a specified XY location. Now actually today's example isn't going to really contain anything particularly different to the Hello World example, because we were doing the Hello World example in a bitmap sense anyway. We were drawing the font ourselves, but I thought it was worth seeing a more streamlined example today that just did the single task of getting an image to the screen, because that's going to be something you are going to want to see in your programs if you're making little games. Okay, so let's take a look. Okay, so here is our source code here. Now, the first thing we've got at the start is the cartridge header itself. This first command here is telling the assembler what kind of cartridge we're creating, because the N64 is big endian, the PlayStation is little endian, so there's little configuration differences in the way those systems work. So we're telling the assembler we're doing N64 here. We're specifying the destination file name here, which is cart N64, and the memory address that that cartridge will start. And then we've got an origin statement here. Now, the start of the cartridge is actually a cartridge header with a variety of defined bytes and a few important definitions. We're defining the start of our cartridge here, for example, here, and the name of the cartridge, so you can put your own stuff in there if you're feeling adventurous. Now, after that, we need a bootstrap, and basically, I haven't written my own bootstrap, so I've borrowed one from a computer game, from one of the existing games. So this was taken from an officially released game. It seems a lot of them use the same bootstrap anyway. I'm guessing Nintendo probably had an official one as part of their development kit, but not all games use the same one. So I would suspect that later on in the development of the life cycle of the system, people found optimizations they could make and came up with their own. So anyway, we've got one included as a binary file here. Now after that, we are going to set up our screen. So we're setting up a variety of the hardware registers from this base register here. There's a whole set of them to set up the screen size and the memory address base. This is our VRAM base here, and we're basically setting up a 320 by 240 screen, which has a 16-bit per pixel color resolution, so 2 bytes per pixel there. So we're not going to look into the details of those. What we're going to look at first, though, is our actual drawing routines here. So this is our main program. So the first thing we're going to do is we're going to clear the screen, and we're going to clear it this color here, so black. Not very exciting, but this is the color, and this is the format of the bytes of our screen. So there's 2 bytes for each pixel, and basically the first 5 bits are red, the next 5 bits are green, the next 5 bits are blue, and then there's 1 unused bit. Now the important thing to notice though on this system is that we are using big endian, so the memory is big endian, and that means that the bytes are actually reversed compared to a Windows PC. Now I'm including the mascot character here. This is the file that is being shown to the screen when we run this example here. So we run this example, we get this mascot here is in this file here. So you would need to create a file, unless you're going to define it entirely as byte commands, for the format of this system. And so what you're probably thinking is, maybe some kind person has created some kind of image editor. Well, you're out of luck, because I've created one, but I'm a miserable git, so you're going to have to make do with it. But this is my Aquasprite editor. It's free and it's open source, and it will export files in the formats required for all of the examples in my tutorials. So if you go to this MIPS menu here and you select N64 and you use this Save Raw Bitmap option here, this will output this or any bitmap here in the correct format for today's example. Now there's also this Save 8x8 font that is for my original examples. That's not actually the correct format for the 1 bit per pixel example. That was actually a Spectrum font for the ZX Spectrum originally, but basically, as I say, you can use Aquasprite editor, and it's free and open source, so you can make it better. If it doesn't do what you need, go ahead and do that. Now anyway, after we've cleared the screen, what we're going to do is we're going to calculate the VRAM destination for our drawing with this getScreenPos function, and this is taking an X and Y position in pixels, and it's going to return a VRAM destination in the register A0. Now what we're going to do after that is we're going to load A1 with our source bitmap data, that Chibico mascot there, and the width and height in pixels here, and then we're going to run draw bitmap, and that will show the mascot to the screen. Okay, let's take a look at all of this then. So our clear screen routine is basically the same as in the previous Hello World example. So we're loading the VRAM base here. The screen size is 320 by 240 pixels, so that's the number of half words we need to write. And then we're just writing A0, which is our color, to the screen that many times until we fill the entire screen. Now, we could store words, that would be twice as fast, but for clarity, I'm working in halves here. So that's just clearing the screen. Now, the next thing we're going to look at is calculating the VRAM destination with getScreenPos. So basically, what we're going to do is we're going to multiply our X position by 2 because there's 2 bytes per pixel. Then what we're going to do is we're going to multiply our Y position by 320 times 2 because there's 320 pixels per line and there's 2 bytes per pixel. So there's 640 bytes per line. So our Y position times 640 effectively. Now, then what we're going to do is we're going to add that to our VRAM base. Now, our VRAM base is that. However, it seems basically the first few lines aren't actually visible. So we're skipping a few lines there. We're skipping 14 lines here. And actually, weirdly enough, and I don't quite understand, this must be something to do with the VSync position, but actually that is 1 pixel across as well, but it's close enough for this example. So that is how we are calculating our VRAM destination, multiplying the Y position by that, multiplying the X position by that, and adding them all together to this to calculate the VRAM destination. Okay, so the last thing we're doing then is actually drawing the bitmap to the screen with this draw bitmap routine. Okay, so well, all we're going to do is we're backing up our VRAM destination here, and we're backing up our width into T2 here. And then what we're going to do is we're going to load a single pixel, a half word there, 16 bits, from our A1 source and writing it to our T1 VRAM destination. And then we're moving the source memory address and the destination memory address across by 2 bytes, 1 pixel. And we're repeating until we've done the entire width of our bitmap. Now, once we've done the entire bitmap, we're basically going to move across and then move down and move across and then move down, which is why we backed up the VRAM destination up here. So all we're going to do is going to add one line, 320 pixels times 2 bytes, to our VRAM destination here, moving down one line. We're then going to subtract 1 from our Y count, and we're going to repeat until we're done. And when we're done, we're going to return. And that's all that it takes to get our example bitmap to the screen. And because of the way this has been done, we could change very easily the X and Y position here, and we could change the width and the height if we're using a different bitmap. So for example, if we get a bit creative here and we change this to 24 and this to 96, and we could change this to 32 and 32 maybe, and we run it again, we will see, well, now our bitmap is being drawn in a different position, and because the size we've defined is now half the actual width and twice the actual height, the lines have kind of got squidged up here, and so the bitmap isn't correct because of that. But if we loaded in a new tall thin bitmap, that would possibly work very nicely. I'm just showing you basically that the draw bitmap routine here is indeed using the width and height specified here, and the getScreenPos is using the X and Y position specified here. So as I say, the idea is this is just a simple template for you to use in your own examples and tutorials and things. So, you know, please make some use of it. Now, I'm afraid we're not going to be doing anything particularly advanced graphically with the N64 in these tutorials. So obviously the N64 is a very capable 3D system to an extent, but I'm only, you know, originally I'm only an 8-bit programmer. I really never planned to go anywhere beyond 16 bits. So the N64 is way outside of the scope of my tutorials, really. I'm just doing some simple things here to get you started. So if you want to see 3D and things, I'm afraid you're going to have to learn that somewhere else, because it's not something I'm going to be covering in these tutorials. Anyway, I hope you found this useful. As always, go to my website, download the source code and the build scripts. If you want to learn about building a ROM cartridge, please see the Hello World example, which I went into great detail on that. Anyway, I hope you've enjoyed what you've seen today. Thanks for watching, and goodbye.